this is back to talking about whether a function is continuous or not. You can talk about several things. You can talk about, and I guess I'll have to write it up here, but you can talk about something being continuous at a point. Why didn't it let me do that? Anyways. You can talk about continuity at a point. You can talk about continuity on an interval. And you can talk about whether a function itself is continuous or not. So for this example, we'll look at each of those three things. If you graph that, I'm not sure if you know what that graph looks like. If you know what the graph of 1 over x looks like, you know what the graph of 1 over x plus 2 looks like. If you don't, you can look at it, put it on your calculator pretty easily. As long as you put the brackets there, 1 divided by x plus 2, it's just 1 over x but shifted 2 to the left. This one, you really do need to go on zoom decimal, number 4. It looks like that. Actually, we'll shift the scale over a bit here. We'll go minus 6.7 to... I just graphed 1 over x plus 2, that function that's down below there. Okay, so that's the graph. If you have it on something other than that decimal one, it tries to connect the two parts. And you can't see the actual, that there's a break there. And some might actually still connect it. I can never quite figure out, some of the calculators seem to try and draw a vertical line there. It's not there, right? The calculator tries to connect the line sometimes. It doesn't matter, as long as you know that it's not really supposed to be there. If you talk about, I need a picture of this so I can draw on it. We need a picture of that. Of course, I moved all my... Come on. Okay. You know what? I'm going to put this whole thing down here because it's hard writing on top of other stuff. Now, let's not get into... I didn't mean to launch any calculator wars over calculators. You can talk about continuity at a point. Okay, this is for example here. At this particular value right here, at this x value, at x equals negative 2, there is an infinite discontinuity. So if you say, is there, what's happening at x equals negative 2? At x equals negative 2, there's an infinite discontinuity, right? One goes up, one goes down. It's a vertical asymptote. Infinite discontinuity is essentially a vertical asymptote. You could talk about on an interval, so that was on a point. On an interval means a range of numbers. So you could say maybe from negative 4 to negative 1. Is it continuous on that interval? Is it continuous on that interval? It's not, right? On the interval, negative 4 less than or equal to x less than or equal to 1. Not continuous on that interval, right? Because now you're saying for all the values in that interval, is it continuous? Well, no, it's not. Even though it's not defined at negative 2, on that interval it's not continuous. But the definition of is it a continuous function? If you say, is this a continuous function? The answer is yes. Okay? It is a continuous function. because it's continuous at every point in its domain. What? Okay, well, I mean, again, think about what the domain is. What's the domain? The domain is, yeah, all numbers except -2. It's continuous for that, right? That's the domain. And it's continuous for every one of those points, right? Yep.
How come this one is discontinuous? The one of the squared.
Where are we talking about? Okay, let's go back down here. I'm going all over the place here, but it's a continuous function because everywhere, no matter where you put this dot on the function, if I move this anywhere, whoops, except off there, anywhere you move this, moving a dot again, when you could go back to the calculator, right? On the calculator, if you trace along this, everywhere where it's defined, it's continuous. It's not suddenly jumping to another value. It's going where you expect it to go, right? Now I know that when you get to this point here, it's not defined at all, and over here it is defined. Every point that it's defined for, it's continuous, even though it has that discontinuity at -2. You'll be okay with this, I'm sure, once we work with it a bit. Well, I mean, that's kind of what limits say, right? The limit definition of continuity at a point we had was if the function is defined to be the same thing as the limit as you come from either side, right? Then it's continuous.